All right, so this is the remaining examples from chapter 4, all of the notes, the things that were extra that we skipped over. So we're looking at section 4.1 right now, but we actually did everything in 4.1. So we're going to scroll down to 4.2 and start with number 2, part C. This was just an extra example of a graphing problem. So we're doing e to the 3x, graphing that. And to graph that, we'll need to make a table of values. So we'll make an XY chart. And then we'll have -2, -1, 0, and 1 and 2 to plug in. E to the 3 times -2 would be e to the -6, which comes out at about 0.002 using my calculator. E to the 3 to the times -1 would be e to the -3, which comes out to about 0.05. E to the 3 times 0 would be e to the 0, which would just be 1. E to the 3 times 1 is e cubed, which is actually 20.1. And e to the 3 times 2 is e to the 6, which is 403.4. So as you can see, this one is growing pretty quickly, and we probably won't be able to graph that last point or maybe even the last 2 points, but we'll try to get as close as we can. So then when we go to graph it, we'll make our scale. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We'll try to get that next to the last point in. Okay, so -2 is at 0.00002, so that's pretty small. I can't really do much smaller than that. The other one is at 0.05, so just a little bit bigger. Then at 1 is at 20, so notice that we can't even graph the rest of this because it gets off the scale way, way, way too fast. So this one has a sharp increase. Okay, so that was just an extra example of how to graph. You just do it with a table. The next one that we skipped over, we looked at example 4 and we did parts A and D, so we're going to look at B and C really quickly. So the formula that we're using is sorry, this is not number 5, number 4. We're using the compound interest formula, and we're looking at a deposit of $2,000. Time is 10 years, and the rate would be 0.09. Remember, our formula is A equals P parentheses 1 plus R over N to the NT. And we want to find the balance for monthly and daily. So for monthly, we'd be plugging in 12 for the compounding amount. So that's N. So 1 plus 0.09 divided by 12, 12 times 10. So my exponent up here is 120. So let's get our calculator. So we'd be doing 0.09 divided by 12 plus 1 raised to the 120th power, and then times by the 2,000. So that would be 4,902.71 cents. Okay, for daily, we're doing the same thing, but we're going to be using 365 for our compounding. So 365 times 10, that means our exponent is 3,650. I always like to write that down before I go to do my formula. So 0.09 divided by 365 plus 1 raised to the 3,650th power, and then times by the 2,000 out front. That's 4,918.66 cents. Okay. Let's see what else we have from this section from the notes. I believe we did all of the rest of 4.2, so now we're moving on to 4.3. There were a couple we skipped there. We skipped number 3. This was the second derivative of this function right here. So we need to take the first derivative first, and then we can take a derivative of that. So y prime would be, this would be just using the rule of how to take the derivative of e to the x. So it's 2 times derivative of e to the x is always itself, but times any chain rule. The chain rule is what is the derivative of the exponent, which is just 3. plus 3 times e to the negative 2x times the derivative of its exponent, which would be negative 2. So this one, y prime, is 6e to the 3x minus 6e to the negative 2x. Y double prime would be 6 times e to the 3x times another 3 minus 6 times e to the negative 2x times another negative 2. So this one becomes 18e to the 3x plus, because it's negative times negative, 12e to the negative 2x. So there's the second derivative of that equation. For B, we're going to be finding the equation of the tangent line to the graph at the point provided. So when we look at this one, we're going to have to first take the derivative of this and then evaluate it at 0 to find the slope of our tangent line at the point. And then after that, we will plug it into the point slope formula. So y prime, this is kind of a power rule here. We can bring the 2 to the front. This is e to the 4x minus 2. That would then be to the first power. And then we take the derivative of the inside. Well, the derivative of the inside has to mean taking the derivative of e to the 4x. It's always itself when you take the derivative times the chain rule of the exponent. So this would be y prime is 8e to the 4x times e to the 4x minus 2. That's if you combine everything. Now we're going to plug in 0 to get our slope of our tangent at that point. So that becomes e to the 0, because anything times 0 is 0. This is also e to the 0, because 4 times 0 is 0. And then this would be e to the 0 is 1. So this would be 8, and then this would be 1 minus 2. So I'm getting negative 8 overall. Now that's our slope. So then we take our slope. So y minus y1, so that would be 1, equals the slope times parentheses x minus x1, which is 0. And this would be y minus 1 equals negative 8x. That would not be there at all. And then we add over the 1. So negative 8x plus 1. Okay, and we did finish the rest of the examples in that section, so that puts us in section 4.4 now. In section 4.4, we pretty much did all of the examples except for the last 2 word problems. So we're looking at number 11. It says, students in a math class were given an exam and then retested monthly with equivalent exams. The average scores S for the class can be modeled by S equals 80 minus 14 ln of t plus 1, where t is the time that is passed in months. So when we look at this first part, it says, what is the average score on the original exam? That would be at time 0, when they first took the test. So this is asking us to plug in t equals 0. So S equals 80 minus 14 natural log of 0 plus 1. This would be 80 minus 14 of natural log of 1. Natural log of 1 is always 0, because when you ask that, it would be e to what power equals 1. Well, that would have to be 0. So this is just 80, because this would be 14 times 0. So the original score, average score, was 80. Now, the average score after 4 months, now this is going to actually go down, because retention, the way when you retain something and you retest, if you're not continually teaching the topics, you are going to lose a percentage of that knowledge. So this would be ln of 4 plus 1, which is going to be ln of 5. So 80 minus 14 times ln of 5. So we need to do that on our calculator. So 5 natural log times the 14, which is negative, and then plus the 80. So now the average score for these students is down at 57.5. Because if they haven't kept up on these skills, they're going to lose that knowledge. And then how many months did it take for the average score to get to 46? Okay, so this is when we set S equal to 46. Now this we're going to have to solve, and because we're going to be solving this, we're going to probably have to turn it into something that has to do with exponentials, since it has a log in it. So if we subtract over the 80, that would be negative 34 equals negative 14 times natural log of t plus 1. Let's get the natural log by itself, so let's divide by the negative 14, so that's going to be positive since it'll be divided by another negative, negative times negative. And then I would reduce that to 17 over 7. And then to get this t out of this argument, we need to turn this back into an exponential. So this would be e to the power over here, so 17 over 7, equals the argument inside. So it's my spiral, but it's kind of going the wrong way. So this would be t plus 1. So the actual formula, if you want the exact answer, is e to the 17 over 7 minus 1, because we'd subtract that 1 over. Now, you're not going to do that in real life. You're not going to tell somebody that's their test score, their average test score. You're going to actually evaluate this as a decimal. So 17 divided by 7 is my exponent. We raise e to that power, and then we subtract 1. And that's about 10.3 months, because this is solving for t. So that's how you work this one out. Next is number 12, which I know shows up in your homework on WebAssign, so let's look at that one. So the hard part about number 12 is that the formula is pretty tough to manipulate, and they've given us the p instead of the x. So we're going to have to do some moving some things around to be able to solve this. It is just a plug and chug formula, but we need to move some stuff around to make this happen. So we're going to plug in the p of 200 that they gave us. So this is 200 equals 6,000. 1 minus 4 over 4 plus e to the negative 0.002x. I would probably distribute that 6,000. Oops, that is not a 2,000, sorry. Let's just mark out that 0. So 200 equals 6,000 minus, when you do this, this would be 6,000 times the 4 on top. So that's 24,000 over, you don't need to do anything to the bottom, all of this. We would then subtract over the 6,000, so that's going to make this negative 5,800 equals negative 24,000 over 4 plus e to the negative 0.002x. You can think of that being over 1. Now I'm going to cross multiply. So this would be, let's see, what negative 5,800 times 4 is negative 23,200. And then we also have to multiply that times the e, so negative 5,800 e to the negative 0.002x, and that's going to be set equal to the negative 24,000. Okay, start solving this. We would add over this 23,200. So this will be negative 5,800 e to the negative 0.002x equals, I know this will be the wrong sign, but I'm going to go ahead and do it since it's already typed in. So it would be negative 800 divide by the negative 5,800. And that'll be a positive now because it's a negative divided by a negative. We can cancel out the group of zeros since they're same on top and bottom. So this is e to the negative 0.002x equals, and that I would reduce that 8 over 58 as well. If you divide them both by 2, that would be a 4 over a, what is 58 divided by 2? Should be able to do that in my head, but it's 29. And then because this x is in our exponent, we want to use the natural log to get it out. So we're going to take a natural log of both sides, and that will bring that negative 0.002x to the front. Natural log of e is just 1. And then we'll have to type in natural log of 4 divided by 29. So our final step, I'm running out of room to write it, is we're going to do the natural log of 4 divided by 29 divided by the negative 0.002 for the x part. So 4 divided by 29, take the natural log of that, and then divide it by the 0.002 that is negative, and that gives me 991 if I round to the nearest whole number. So it's approximately 991 units that they need to sell, because X stood for units. And that's it for that one. Okay, so that puts us into the last section. And there were a few examples we skipped over in this one. So 4.5, we skipped over number 6, taking this derivative that had this product rule inside of it. So remember, the derivative of natural log of x is 1 over the x. The x is the argument of that, times any chain rule that you get from that inside part. So for us, this would be natural log of this big blob here would be 1 over everything inside, but we have to then chain that times whatever the derivative of this denominator is. So because that is a product, you can think of it as x squared times x minus 1 to the 1/2, we're going to have to do the product rule. So derivative of the first would be 2x times the second, which would be x minus 1 to the 1/2, plus the first one times the derivative of the second, which would be 1/2 x minus 1 to the negative 1/2. So this is going to be 2x square root of x minus 1 plus x squared over 2 square root of x minus 1. That's just for this derivative up here. And I would try to get a common denominator here. I'm going to multiply this top and bottom by square root of x minus 1, which actually just makes this just x minus 1. So that would be 2x squared minus 2x plus the x squared on top. So that's going to be 3x squared minus 2x for my top. And then I have a 2 on the bottom. And then I have a square root of x minus 1 times, adding, we keep it the same denominator. So we missed one thing here. Hang on just a second. I needed a 2 also on this. So this is actually 4. Because if we're getting a common denominator, you also needed the 2 in the denominator. So this would be 4x squared minus 4x. So this is actually 5x squared. So sorry about that. So let me rewrite this. Hang on just one second. Okay, so I'm going to rework this part about the derivative real quick. So we have, remember, it was x squared times the x minus 1 to the 1/2. Using the product rule, that would be 2x times the x minus 1 to the 1/2 times x squared times 1/2 x minus 1 to the negative 1/2. And the chain rule would be a 1 here, so we don't have to add that on. So that gives us 2x square root of x minus 1 plus what we had, which is x squared over the 2 square root of x minus 1. And to get a common denominator, we multiply top and bottom by x minus 1 under a square root again, and a 2, because this has a 2 in the denominator. So that makes this 4x times x minus 1 plus x squared on top over 2 square root of x minus 1. And then that gives me 4x squared minus 4x plus x squared over the 2 square root of x minus 1. So that makes this 5x squared minus 4x over the 2x square root of x minus 1. Now you would typically combine this together, and it's actually going to turn out to be a nice answer. It's really interesting. So I'm going to go up here so I have a little room to write this. So up top I have a 5x squared minus 4x because you multiply that times 1. On the bottom, I have a 2x squared, and then the square root of x minus 1 times another square root of x minus 1 is just x minus 1. Now we can pull an x out of the top, and the reason we would do that is because there's an x out front down here that we can cancel with that. There's actually 2 of them, but we're just going to cancel 1. So my final answer for this one is 5x minus 4 over 2x times x minus 1. So that's the derivative of number 6. Okay, then number 7, we needed to find the equation of a tangent line. So we need to take the derivative of this. So if we do, this has got a product rule again because you've got the x there. Derivative of 2 is just going to be 0. So we have 3x as our original function there, and g of x is going to be the natural log of x. I'll call this h of x so it doesn't match the original function. So the derivative of this one is 3. And the derivative of this one is 1 over x. So remember, derivative of the first, which would be 3, times the second, which would be natural log of x, plus the first times the derivative of the second. So this becomes 3 natural log of x plus just 3, because the x's cancel. And then we evaluate that at 1 to find the slope of the tangent line. Okay, and the natural log of 1 is 0, so then we get just 3 times 0 plus 3, so that's going to be 3 for my slope. So then y minus 2 equals 3 parentheses x minus 1 using point slope, which would be 3x minus 3. Add the 2 over, so we get y equals 3x minus 1. So there's our equation of our tangent line. The only other one we had left that we did not do in class was number 10. So this one is a group of 200 students was tested every 6 months over a 4-year period. The group took Spanish their first semester of college and then did not take any more Spanish classes. So they haven't been reviewing Spanish. The average test score P in percent is modeled by P equals 92.3 minus 16.9 natural log of T plus 1 for T between 0 and 48 months. At what rate was the average score changing after 1 year? So now this part right here is telling you that we need to take a derivative because they said the rate was changing. Rate changing is slope. So because this is 2 different variables, we're going to take it with respect to time because it's the 1 year. So dp dt equals, because that's this, so the derivative of 92.3 would be 0. The derivative of negative 16.9 natural log of t plus 1 is negative 16.9 times the derivative of natural log, which is 1 over t plus 1, and the derivative of the t plus 1, the inside part, is just 1. So it's just going to be negative 16.9 over t plus 1. Now, we are using 1 year. Now, the trick here is some people will plug in 1 here and you're going to get the answer wrong because time is measured in months. So this is 12 months. So this is negative 16.9 divided by 12 plus 1, which is negative 16.9 divided by 13, which is approximately negative 1.3. So this would be an average score would decrease by 1.3%. Since we have a negative, that's the decrease per month. So that's what they would lose in their retention for not doing Spanish during those months. Okay, and that is the end of all of the extra examples from Chapter 4.